I just wanted to start my presentation actually by thanking Emily and Keith for the hard work and the collaborative work with UN Environment Program for the work done on data reporting for the SDG 1411 coastal eutrophication. Next slide, please. Okay, in case at the end of the presentation you have any questions, you can please email one of us, Emily, Keith, or myself. Next slide, please. Okay, I will start my presentation actually using the following quote for our previous Secretary General, Mr. Ban Ki-moon. Saving our planet, lifting people out of poverty, advancing economic growth, these are one and the same fight. We must connect the dots between climate change, water scarcity, energy shortage, global health, food security, and women's empowerment. Solution to one problem must be solution for all. The Sustainable Development Goals actually are very important to achieve the previously mentioned objectives. That's why we want to share with you our project on filling the SDG data gap using satellite imagery and GIS tools. The Sustainable Development Goals framework actually is formed of 17 goals, 169 targets, and 244 indicators. UNEP is the custodian agency of 25 of these indicators across goals 6, 8, 12, 14, 15, and 17. The role of the custodian agency is the implementation, and specifically UNEP, is the implementation of the 2030 Agenda for Sustainable Development. The Resolution 2/5 of the United Nations Environment Assembly in the context of the SDG indicators encourage the Executive Director to continue UNEP's work in a manner that avoids duplication on indicators to support monitoring the delivery of the environmental dimension of the 2030 Agenda for Sustainable Development Goal. For Sustainable Development. Next slide, and Emily, to you, please.
Thank you. So now I'll talk to you about work that we've been doing on an SDG indicator for SDG 14, which is the indicator for the oceans, life below water. And one of the indicators is related to marine pollution, and it includes an indicator on an index of coastal eutrophication. And eutrophication is a process where you get nutrients, especially nitrogen and phosphorus, that will lead to increased growth and primary production of algae, which can cause issues for organisms in the water, such as hypoxia, as well as other issues with water quality that can be a real challenge for the environment. And one challenge for this indicator is that eutrophication is measured in multiple ways. So the direct measurements would be using in-water analysis of nitrogen and phosphorus to identify the nutrient pollution. There also are indirect measurements, so such as looking at the impacts of eutrophication on the biology, so looking at algal blooms. And along those lines, you can use chlorophyll-a, which is a photosynthetic pigment, as a proxy for algal blooms. And working with UN Environment and member countries, one big challenge is that a lot of countries do not have the nutrient data to actually report on the level of eutrophication. And so we have been working with UN Environment and Esri to put together the methodology for this that includes several sub-indicators that focus on the indirect measurements, including some that you can use satellites for. So satellites can detect changes in ocean color and chlorophyll-a. And so we've worked with Esri and UN Environment to develop the methodology for a couple sub-indicators that are using global satellite data. And these methodologies are broken down into 3 levels. So the first level are derived from global data products. And so this is what we'll be focusing on today. And so for this, we have put together 2 sub-indicators. One that is looking at national contributions to the index of coastal eutrophication potential. And then the ones that are using satellite data are looking at sub-indicators for chlorophyll deviations and anomalies. There also includes in the methodology level 2 indicators, which are looking at specific chlorophyll-a concentrations, which can be derived from satellites or in situ measurements, and then looking at what is an appropriate level in a certain region, and then looking at national modeling for coastal eutrophication potential, as well as the in situ concentrations of nitrogen, phosphate, and in silica, which is important for diatom algal blooms. There, furthermore, is if countries have this available, level 3, which includes some supplementary indicators. So that relates to nutrients and riverine discharge that would be impacting coastal eutrophication. And we're also looking at including some additional information, such as looking at land use change that could be driving eutrophication. And so we'll focus the presentation here on the level 1 activities that we've been doing, specifically the chlorophyll-a deviations and anomalies. So I'll turn it back over to Danny now to talk about the workflow and the processing that we've done in collaboration with Esri for these 2 sub-indicators.
Thank you, Emily. Here we're showing actually the workflow, how the data was calculated. We actually have the monthly baseline derived from the monthly 2000 to 2004 monthly average from January to December. And we had the monthly satellite reading for the chlorophyll-a. So we calculated the monthly chlorophyll-a minus the monthly baseline. Then we divided over the monthly baseline, multiplied by 100 in order to calculate the percentage change or percentage impact or deviation. Then we selected the positive values, and then we clipped the global EEZ in order to calculate the 90th percentile and classify the pixels as deviations based on the 90th percentile. And then we took each and every national boundary, EEZ boundary, and summarize the pixels where we identify positive values by country's EEZ. And then we come up actually with the monthly summary table for the chlorophyll-a deviation. This monthly summary table has been also derived or calculated the yearly average, which is then reported to the SDG global database. Next slide, please. This actually, the map show the sub-indicator on a monthly deviation, how it's changed from month to month. You can see it's all based on the EEZ for countries. Next slide, please. This is the workflow actually for the second sub-indicator. It's similar to the previous sub-indicator 1. But here we are measuring actually the chlorophyll-a anomalies, also based the same calculation, but here we also measure the frequency of the anomalies. If the pixels or it's in the 90th percentile, then it's moderate. It's high if it's 95th percentile or 99th percentile. And then we divided actually over the total number of pixels in the EEZ, and then we get the proportion or the percentage. Then we calculate the yearly average based on the sum of the 12 months divided over 12. Then we calculated actually the anomalies per frequency, and then this actually calculate the yearly moderate statistics or yearly high statistics or yearly extreme statistics. And these all actually reported to the SDG global database. Next slide, please. Here actually is showing both the chlorophyll concentration on the left side screen and the chlorophyll anomalies at the right side screen of the screen. So algal bloom index, we have the moderate, we have the high, and we have the extreme. Next slide, please. This is actually how the frequency was calculated. We have the value. It's a monthly moderate occurrence over the total monthly occurrence. Then we come up, and then it's summarized by the country EAZ, the count and the mean. This is actually calculated for the 3 frequencies. Next slide, please. Here we're actually hoping to in the future to start working with governments or with regional Cs or groups in order to start collecting the level 2 data on chlorophyll concentration, national modeling of the coastal eutrophication potential, and in situ concentration of nitrogen, phosphate, and silica, as Emily mentioned previously. Next slide, please. Thank you very much. In case you have any question, it can be sent to our emails. Thank you.